Hi everyone, welcome back to next session. Today we are going to discuss about two-way classifications problems by using RBD, right? So two-way ANOVA. What do you mean by RBD? As I said earlier, randomized block design. So for solving two-way ANOVA problems, we have to use this RBD technique. So in one-way ANOVA, we classify populations according to one categorical variable or raw factors. In the two-way ANOVA model, there are two factors, each with several levels. So this is the major difference between previous method one-way to this method two-way ANOVA. When we are interested in the effects of two factors, a two-way design offers great advantages over two single factor studies. Right? This is the introduction about RBD. Now, is there any notations for two-way like one-way? Yes, of course it is there. So here I am mentioning number of levels of row factor is R, number of levels of column factor is C. Total number of observations is multiplication of these two, R into C. Observation in ijth cell of table is equal to xij, where I runs from 1 to R, j runs from 1 to C. That means row wise, column wise. Right. So even I would like to add up one more point. In one-way classification, we will check either row or column alone. So in our case, previous problem we discussed columns. The errors of technicians are given in the column wise. No, here row also included. That is what difference between CRD and RBD. Now, sum of C observations in ith row is equal to TRI. That is, it is observations along rows, which is equal to summation of xij, where j varying. Sum of R observations in jth column is denoted by TCJ, which is equal to summation of xij I varying. Sum of all RC observations is equal to T, so which is nothing but combination of both row and column, summation of ij xij, right? And this is what very important, total sum of squares, which was already discussed in one-way classification. SST is equal to double summation I and j xij square minus t square by RC, right? Here additionally SSR is added. Between rows sum of squares is equal to summation TRI square by C minus t square by RC. Between column sum of squares is equal to SSC is equal to TCJ square by R minus t square by RC. This is formula after all. And error sum of square SSE is equal to SST minus SSR minus SSC. So the major difference between one-way and two-way is here row terms are ordered, SSR is additionally coming, and for finding SSC, that SSR has to be subtracted in right hand side. This is the difference between one-way to one-way and ANOVA to two-way ANOVA. Now, what is the table? ANOVA table for two-way classifications. For a two-factor analysis of variance, this takes the following form. Again, source of variance here between rows, between columns and error. So in our previous case, column alone has came. Sum of squares is SSR, degrees of freedom is R minus 1, mean square is MSR, and F ratio, which one is the highest value, that will come in numerator, MSR by MSE. Between column means SSC, its degrees of freedom is C minus 1, mean square is MSC, F test formula is MSC by MSE. That error term will come in denominator for both cases, right? And the error sum of squares formula is SSE, degrees of freedom for this case is R minus 1 into C minus 1, mean square is MSC, right? Again the same technique whatever we discussed in our one-way case, same F formula we are going to find out with respect to table. Now this note is very important. The three sum of squares SSR, SSC and SSE are independently distributed. For the degrees of freedom, R minus 1 plus C minus 1 plus R minus 1 into R minus C is equal to RC minus 1. So using the F ratios, test for significant row effects and for significant column effects can be undertaken. So for row effect, H0 is equal to no effect due to row factor, and its alternative is an effect due to row factor. Similarly, we can write no effect due to column factor, and H1 will be an effect due to column factor. Like that we can write. And the critical region F is greater than F of r minus 1 comma r minus 1 into c minus 1. Again here also we can write the critical region. Ultimately here I am telling test statistics FR, with FR means row. The formula is MSR by MSC. This is what I have written in the previous table. And similarly FC with respect to column value, F value for F value with respect to column is equal to MSC by MSC. So these are all some point you have to remember while you are writing the table for two-way classifications. In next class we will discuss one problem based on these two-way classifications. Thank you.